Alright, in lesson 5-7 we were working on scatter plots, correlation, and lines of best fit. So what we're going to work on is graphing a scatter plot and then being able to graph and write the equation for the line of best fit. So when we look at our information here, if we do this first table, talking about jean sales, X is always on top in our table, Y is in the bottom. So on our X scale, we know we're going to be talking about the average price. We want to label that axis. Average price in dollars. We want to give the entire graph a label, which is jean sales. And then the y-axis is going to be the number sold. So now we can plot our points. Looking at our x-axis, we need to get all the way up to 40. So in this space, we want to figure out what we can count by to get up to 40. This corner is going to be 0 for us. So to get up to 40, let's see if we can count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. That would be plenty and we have extra space. So let's do that. If we have 5 here, 10, 15, 20, 25, 30, 35, 40, 45, 50, and we'll do a couple more. Then we want to label our Y scale, the number sold. We have to get all the way up to our highest number of 130. Again, this is 0, it's in the corner. We have to get all the way up to 130. In this space, we maybe want to count by tens. We have a large space, so it'll be 10, 20, 30, 40, 80, 100. Notice how each 2 squares is 20, so 1 square is 10, a value of 10. Alright, and now let's graph these points. So at an average price of $21, it goes up to 130. Then for $28, it goes all the way up to 112. For $36, it's going to go up to 82. $40 for a pair of jeans goes up to 65. Now we have our 4 plots, our 4 points. We can see that it's going down from left to right, so this is a negative correlation. And now we need to draw our line of best fit. We want to get it right in the middle. It's going to be our trend line, going through as many as we can, but also still in between. If you look here, it's on the edge of 3, and only 1 is on the other side. So we're going to put our line right about here, all the way through our graph. And we're actually going to stop it there. We can't have a negative number sold, so it's not going to go down farther. And we also can't have an average price that is negative, so it's not going to go farther to left. It'll stop right at each axis. So now we have our line drawn. We need to write an equation. If the equation is going to be written in slope-intercept form, we need 2 pieces of information. We need the slope and we need the y-intercept. If we look at the slope, we want to find 2 spots on our green line here that are easy to measure. I want to see where is it crossing nicely on our grid. So I see 1 point right here I want to use, and another point we'll say right here. So we're going to use these 2 points to get our slope. So it's going to go down, a fall, and then a run. If we count, this is actually at 120, so it's going down 10, 20, 30, 40, 50, 60, 70, 80. It's going down 80, and then we're running from 25 to 35 to 45 to 50. So this is going to be 10, 25. So now, when we write our slope, it's going to be rise over run, or in this case, fall, which ends up being negative 80 over 25. We can always simplify that. In this case, we'll divide them both by 5. Giving us a negative 16 fifths. And we're going to leave our slope as that. It happens to be just that. So m is going to be negative 16 fifths. Now we need to find our y-intercept. Our y-intercept is where it crosses the y-axis. When x is equal to 0, that is our y-intercept. So we look here, it looks like it's crossing the y-axis right at about 200. So our y-intercept is going to be 200. Now we have everything we need to write our equation. Y is equal to negative 16 fifths x plus 200. This is the equation for our line of best fit. Now let's do an example where we can use our calculator to actually create that line of best fit. So when we're using our graphing calculator, you'll want to have your sheet to help you with the steps along the way. So this one specifically is an example where we have an x value that are years. Rather than having 1998, 1999, all of these years typed into our calculator, we're going to use 0 for our first year given. So 1998 is the first year given to us. We're going to put that into our calculator as 0. 1999 is 1 year after 1998, so that's going to be 1. 2000 is 2 years after 1998, so that is going to be 2, and so on. (2007) is 9 years after 1998, so we'll put that in as 9. You'll notice here that if this is our x value of 0, this is going to be an important point for us later on, but I'll come back to that. So now let's go through and set up our calculator. We also want to start by clearing it, so we're going to go second 0, 7, 1, 2, and second 0, 7, 2, 2. And now we're ready to go. The first step is to create our list of data. So we click the list button right here on our calculator, and we'll type in our list. For our list 1, those are our x values. We decided that we weren't going to use 1998 through 2007, we're going to use 0 through 9. So we'll type those in. Making sure that we type them all in correctly and that they all match up as an ordered pair. So with 0, we have 1,289 million tickets sold. With 1, 1,311. 2 is 1,340. 3 is 1,339. Filling in the rest of the table accurately. Eight again should be 1,472, and 9, 1,470. So we've typed in all of our values, double checking that they end at the same point. We have the same number of x and y values. So now we've done step 1, entering them into our table. We want to make sure that our graph is going to show this window. So we're going to click the window button and set it specifically to this graph. In this case, our x values went from 0 to 9. So that's what we want to take into account. We want our x minimum to be 0, and then our maximum to probably be at least 10. And then our x scale, we can just count by ones there, since it's not a large range. When we look at our y minimums, the smallest value we see is right here, so we'll maybe go a minimum of 1,250 on our graph. With a maximum, we have to get at least up to 1,470. So we'll go 1,500 for our max on the y-axis. And for our scale, because that's a little bit larger, we can count by, we'll say 20 this time. Okay, so at this point, we've put in our values, we adjusted our window to show it correctly. Now we have to make sure that our calculator is actually going to show those points. So to do that, we need to click on the plot, which is going to be second y equals, and you'll see here that our plot 1, which we entered in our values, is off. So with the 1 highlighted, we need to click enter, and then it's flashing on, so click enter again. So now that plot is on. Now we want to check to make sure that it actually worked to graph. So if we click graph, our points should be shown. So right before step 3, we want to make sure that the graph actually works. Now that we know the graph worked correctly, we're going to find our equation, meaning we need to find the slope and the y-intercept. To do that, we need to click the second and then list value, because above list is the word stat. We're trying to find a statistic, and we want our calculator to calculate. So we arrowed over all the way to the right, so our calc is lit, and we're gonna go down to number 5. So you can either highlight the number 5 and click enter, or click number 5, because we're going to have our calculator calculate the values for a regular linear equation, and then click enter. At this point, you see that the equation on there is y is equal to ax times b. The a is in the place of our slope, so really our slope is the a value on the calculator. We're going to round that to the hundredths place, so it's going to be 21 and 45 hundredths for our slope. Our y-intercept, again rounded to the hundredths place, will be 1,296 and 78 hundredths. So now we can write our equation. With all of this, our equation is going to be y is equal to 21 and 45 hundredths x plus 1,296 and 78 hundredths. You'll notice here that really our y-intercept should be exactly this, but our line isn't going exactly through that. You'll see that it's close. This is our point on the y-axis. Our line doesn't necessarily go through that. So this is going to be our y-intercept, and this is our equation. Now we want to check to see how good is our equation in representing our data. That's what our correlation coefficient does. It's a scale from -1 to +1, and our calculator will give us that value as well. So to do that, we want to flip over to the back side of our directions. To find the correlation, we again want to hit the second key, and then @ because we're trying to find this VARS value. And we're trying to find a statistic right now. So we're going to go down to number 3 and then go over to EQ. And we use the variable R to represent correlation coefficient. So we're going to go down to R, number 5, and click enter and enter. Our correlation coefficient is right here. So looking at that value, because it's from -1 to 1, it's like a percent written as a whole number or a decimal. It's a positive value, and it's almost a +1. So we know that our data points and our line of best fit are showing a positive correlation, and it's a fairly strong positive correlation. Because it is super, super close to that +1 value. And we've created our equation for the line of best fit using our calculator and our directions on our sheet. For our final example, let's say we had a table with x and y values here, and we wanted to put it in our calculator. Remember, we don't want to type in 1978 for a year. When we are working with years and years only, the first number given to us that we type in is going to be 0. That's our starting point. So this is going to be like our 0 year. 1988 is 10 years after 1978, so that's going to get the value of 10 in our calculator. 1998 is 20 years after 1978, so that would get the value of 20. 2003 is 5 years after 1998, so it's another 5, so that one would be represented with 25 because it's also 25 years after 1978. Another 5 years later, that would give us 30. 5 more years later, that gives us 35. And 10 years after that would give us 45 in our graphing calculator. That way we're not typing in 2023 for a year. Notice how from 1978 to 2023, that is 45 years, so that's why we put the 45 in. Let's say we created that equation, and then we wanted to find, well, what would it be in 2043? The value we would plug in for x wouldn't be 2043. We would plug in to our equation for x the number that represents it according to our calculator, because that's where we got our equation from. So 2043, we would have to see how many years after 1978 that is. Well, if we know 2023 is 45 years later, this is 20 years after that, so this is going to be 65. 65 is what we would plug in for x into our equation to figure out how many our result would be in 2043.